everybody. I think I have the video you need. I've been talking about thinking tools. I think it hasn't been making sense to a lot of 7th block anyway. I'm going to show you carefully how you can use a graph to think. It'll be slow, it'll be careful. I really think that all of these problems will feel extremely easy once you kind of make this transition. Because they are actually all extremely easy. They only feel hard right now. Okay, so what if I want to do this? I want to write some equations so that I have a point that moves along the y equals x squared equation, except I want at time 2 to start here at 4:16, and then at time 9 I want to move down to 1:1. So I'm moving that way along y equals x squared. Okay, well, how would you start writing these equations? There's a lot of information in here. It's not really clear. So one thinking strategy is don't try and solve every part of the problem at once. Let's break it into pieces. And a good first piece to tackle is forget the y-coordinates. How can I just control my horizontal movement? How can I just control the x-coordinates? So now's where you can use a graph to think. I know some very specific facts about the x-coordinate at specific times. So we're gonna plot those facts on a graph. So pause the video and ask yourself, what's a time where I know the x-coordinate, and what's another time where I know the x-coordinate, and plot those points. Okay, so here I've got at time 2, my x-coordinate should be 4. So let's plot that. At time 2, x-coordinate 4. And then I know later on at time 9, I want my x-coordinate to be 1. So my graph is not long enough, but we control the graph. So let's make 9 be out here, and then I'll have an x-coordinate of 1. So what I know is if I could come up with an equation that connects those 2 points, and it could be whatever equation I want. It could be linear, it could be quadratic, it could be exponential. But as long as the equation here goes through those 2 points, what it means is that if I plug in time as 1, it'll give me an x-coordinate of 4. If I, 2, it'll give me an x-coordinate of 4. If I plug in time as 9, it'll give me an x-coordinate of 1. And so I know that that's going to make the x-coordinates do exactly what I want them to do. And it's really easy to write the equation for a line based on 2 points. You know how to do that. So what I'm noticing is my x-coordinates decrease by 3 as my time increases by 7. Remember, because it's like rise over run. So that means negative 3/7. And then I'm going to shift over by 2, up by 4. So time minus 2 plus 4. So this is now an equation that I know is going to control my horizontal movement. Time 2, I'll be here. Time 9, I'll be there. But we don't have y-coordinates yet. We're just saying, moving along this way. So let's rewrite the equation. And the whole idea of parametrically defined equations is if you need to go along a path, my y-coordinate is still going to be whatever my x-coordinate is squared. That's what it means to have xy coordinates on this path. Every single xy coordinate, the y is the square of the x. So I now have an equation that tells me my x-coordinate. So if I want to know what my y-coordinate is, I'll take the equation that tells me my x-coordinate and I'll square it. Because if you imagine plugging in a time, that's going to tell you your x-coordinate, and then you're going to take that x-coordinate and square it to get your y-coordinate. So it's sort of like a 2-step process to find the y. And we're done. So I think so this problem is actually very, very simple. I think what makes it complicated is the fact that there's so much information happening at once, and that's why you need a thinking tool. You need to say, okay, I'm not going to do the whole thing. I'm just going to look at horizontal motion, and there are 2 facts that I know about my horizontal motion. And if I can think about those 2 facts separately, now I can write an equation that makes it do what I want. Okay, let's look at that same idea applied to circular motion, because it's not a different idea. It's not a different problem. It's not a different type of problem even. So I know that if I wrote x of t is cosine t and y of t is sine t, that would make me start here on the unit circle and move around the circle in this direction. Okay, but what if I wanted to start over here at time 0 and end over here at time 4? Same issue. It's like, okay, well, I can't solve that whole problem at once. So maybe I'll just figure out what should my x-coordinate be. But the problem is I know my x-coordinates need to follow this cosine pattern where they're going to kind of oscillate back and forth. So what I really need to control is I need to ask at different times, what's the angle that I'm going to find the cosine for? Because remember, cosines take an angle and turn them into an x-coordinate. So if I want my x-coordinate, really what I'm saying is time is going to change the angle that I'm looking for x-coordinates for. So same tool. I know time is going to be affecting angle. Let's ask how. So I noticed that at time 0, I want this angle. Let's use radians, even though you might not be fully comfortable. This amount is pi over 4. You can just count up. Pi over 4, and then here's another pi over 4, and then here's another pi over 4. See, each of these pizza slices is pi over 4. So I've got 1, 2, 3 pi's over 4. So at time 0, my angle is going to be 3 pi's over 4. Okay, let me put a point there. I know that later on at time 4, I want to have this angle. So let's add that as a point. At time 4, that's just 1 pi over 4. So I'll put that down here. Okay, and now I know I can connect that with a line. So let's write the equation. I know that this difference, if I'm going from 3 pi's over 4 down to 1 pi over 4, I have subtracted 2 pi's over 4. So like 3 pi over 4, 2 pi over 4, 1 pi over 4. I went down by 2 pi's over 4. So, and that happened over the course of 4 seconds. So let's write it unsimplified first. So I know I went down by 2 pi over 4 over the course of 4 seconds. That's not a negative sign. That's a little thing. And so we'll simplify that slope in just a second. And then I don't need to do a horizontal shift. I already know the y-intercept. So let's actually just keep that as time, and then I'll shift it up by 3 pi over 4. Okay, how does that simplify? Let's simplify the 2 divided by 4 is really like 1 divided by 2. And then 1/2 divided by another 4 is like 1/8. So here I've got pi over 8 time, don't know why I did the parentheses again, divided by 4. Okay, so what have we figured out? We have now written an equation that tells me the thing I want to control, which is my angle, as a function of time. And I did it by writing down the 2 pieces of information I have. So now, if I write that in here, pi over 8 time plus 3 pi over 4, you can double check that this works. You could plug in time equals 0. If I plug in time equals 0, I get an angle of 3 pi over 4, like I want to. Oh, lost the negative sign. It's a good reason to plug stuff in to double check. If I plug in time equals 4, I'll have 4 divided by 8 is pi over 2, negative pi over 2. And so if I have, which is like 2 pi's over 4. And so now if I have 3 pi's over 4 and I subtract 2 pi's over 4, that gives me 1 pi over 4, which is what I wanted. If that's like too much in your head, you could write it out. That's okay. But it's good to verify that when you plug in the times that you want, you actually do get the angles that you want. And then, I want to use the same angle in both equations because the angle literally tells me what's the angle I'm trying to find the x and the y coordinates for. And then as the angle changes, the xy coordinates are giving me my path around the circle. So let's put that same equation in here. And we're done. Let's do one more problem that was similar to the accelerate the car downwards problem. So here's the path. Let's say at time 0, I'm at a y coordinate of 20. And at time 10, I'm at a y coordinate of 5. Here the difference is instead of x as a function of time, x isn't changing. I can write my x of t equation right away. X of t is always 5. See? X isn't changing at all. So this is a y of t equation. Let's encode what I know. I know at time 0, I want y coordinate of 20. At time 10, I want y coordinate of 5. So I could connect these with a linear equation, which would give me a y of t equation. So let's think about rise over run. So this is change of 15, while this changes by 10. So 15 over 10 is the same thing as 3 halves. We'll do that in a second. And then the y-intercept is 20. So let's add 20. Okay, so I could do that. What type of motion is this going to generate? Well, imagine as time is moving at a constant rate, it's like every additional second that I add for time, my y-coordinate is going down by the same amount. My y-coordinate is going down, let's make this 3 halves. My y-coordinate is going down by 3 halves. And so that's going to make constant downward movement. Every single, so like 1 second, I go down by 3 halves. Another second, I go down by 3 halves. Another second, I go down by 3 halves. Okay, well, what if I wanted to accelerate? Let's put those same 2 points, because we know that no matter what happens in between, at time 0, I want to be at 20, and at time 10, I want to be at 5. So what are some other equations we could choose? Let's choose quadratic equation. There's a bunch of different quadratic equations that go through these points. There's actually an infinite number. One that I could choose is like, let's make that the vertex. And you could think about that one. A different one that I could choose, which I'll do in a different color, is let's make this one be the vertex. And it could look like this. Okay, so think for a minute. As time increases, like which curve is going to make me go faster and faster and faster? Pause it and think for a second. I hope you said the purple curve, because if you think about it, initially if I add 1 second, I've hardly changed my y position at all. If I add another second, I change it by a little more. If I add another second, now I'm changing my y position by more. If I do another second, now I've changed it by even more. So each additional second, my y position is changing by more and more and more, and that makes it feel like I am accelerating. So I think the purple curve is the one that makes sense. Okay, how can we write a quadratic curve that goes through these points? You've done a lot of this, over the last month. So let's just bring those skills in. What do I know? I know that's the vertex. So I'll say y equals, well, so now I want to think about my labels here. Yeah, I guess that's fine. So we'll do that. So t, I'm not shifting it left or right at all, so it can be t squared plus 20. But I don't think that quite, so that does go through this point. Plug in t equals 0, I get a y-coordinate of 20. But if I plug in a t of 10, then I get 120. So that's like a parabola that goes up this way. So I need to solve for a scale factor. Or you could, add a vertical reflection and then solve for the scale factor. I want it to go through 10, 5, so let's do that. 5 equals k times a t value of 10, so 10 squared gives me 100. So now let's solve for k. I'll subtract 20, and so now I'll divide by 100. So negative 15 over 100. And now I can write my quadratic. Y equals negative 15 over 100. And then t squared plus 20. So again, every single step here is very simple and you know how to do it. I'm trying to teach you how to think independently by asking, what do I know? How can I write that information down? What do I want it to do? Okay, I want it to accelerate. So what are my options? A lot of people just jump straight to exponential. When you could do that, like you could definitely write an exponential curve that goes through these, but you need to have some way of making sense of it for yourself. And the way that I make sense of things is with graphs. If you make sense of things with tables, that's okay. But if you've tried to do tables and you're not actually making sense of things, I think that's a clue that that's not working for you, and you should find some other strategy. Anyway, I hope that this was helpful, and I hope you see that these problems aren't as hard as they felt originally. You just have to be able to think your way through them using little step-by-step questions that you ask yourself.